in section 1.6, and this part is where we're solving radical equations. Now, remember when we first started this, we talked about something that you had last semester. So the one from last semester was something like this from last semester. So you had, let's say, the square root of 3x minus 1 equal 5. All right, so you want to solve this radical equation. Remember, it's called a radical equation because of the radical symbol. Square root, cube root, fourth root, fifth root, sixth root, and so on. And what you're trying to do is solve for the variable x. So you have to somehow get rid of the square root. Now remember, the square root, this index is understood to be what number right here? 2. So you to get rid of the radical, you're going to raise both sides. Raise both sides to a power equal to the index. So if this was cube root, you'd raise both sides to what power?
2.
No, cube root, the third power. This were fourth root, you'd raise both sides to the fourth power, and so on. And here is going to be a square root. So I need to raise both sides to what power?
2.
The second power. So you're going to do something like this. So this side squared and this side squared. And then the square and the square root undo each other. And so you're left with the radicand, which is 3x minus 1, equal, and then 5 squared is 25. And so notice I went from a radical equation to a linear equation. And then all you do is just solve for x. You're going to add 1 to both sides. So I get 3x equal 26. And then to get x by itself, I divide both sides by 3. So 3 divided by 3 is 1. 1 times x is x, so x is 26 divided by 3. Right, so that's from last semester. So last semester, basically you had the radical on one side and a number on the other side. In here now, you're going to have variables on both sides. And so that's the one. We only did one last class period, so go back to the notes that you just picked up. It's on that last page, the one that we did.
Yeah,
Okay.
it's 20 minus 8x equals x.
Right. Okay, so this one is actually on page, if you it's in your book that I'm using, page 185, and this is number 14. And so you have the square root of x plus 10 equal x minus 2. All right, now remember, when solving a radical equation, you have to make sure the radical is by itself. Okay, get the radical by itself. So in this case, it's a radical by itself. It's the square root on one side by itself. Yeah. Okay, it is. It's like if I had this, the square root of x plus 10 plus 2 equal x. Is a radical by itself?
No.
No. I'd have to subtract 2 from both sides. And then combine like terms, I get the square root of x plus 10 equal x minus 2. That's a 2.
Okay. Just making sure.
That's a 2. So if this was a problem, you'd have to get the square root by itself. And in this case, it already is. Okay, so then the next step is to raise both sides to a power equal to the index. So raise both sides to a power equal to the index. Right, so it'll be 2. So the next step, I'm just going to go ahead and rewrite this over. And so when I rewrite it and I square both sides, the left side should be easy. The square and the square root undo each other, so what's left on the left? Okay, now on the right, what am I squaring?
X minus 2.
So I'm squaring a binomial, right?
Right.
Okay, so I'm squaring a binomial.